All right, guys, so today's video is kind of our next level up from our similarity proofs we've been doing. So we're on this page in your notes. So we've been doing a lot of this angle-angle similarity, where we look for two angles and that proved the triangles are similar. So what we did a lot of last unit was solving for missing sides. That's really all we're going to do today. We're just going to turn it into like a proof version of this. So if you look at the triangles I drew for you here, this is that page in your notes. And I'm going to do this like more of an algebraic example for this one. So it tells us in the given that the triangles are similar. So I made up some values here and I redrew my triangles, which I've been telling you to do over and over and over again. So hopefully we're getting used to that. But if I'm asking you to solve for x, what we've done is basically after we know the triangles are similar, we know that we can set up a proportion. So I can say 2 is to 6 as x is to 9, for example. All right, we've talked about we can set up different proportions as long as they're kind of consistent. So the reason I know that I can do that is because corresponding sides, so sides that match up, corresponding sides of similar triangles are proportional. All right, you can write that in your own words, but that's kind of how I like to say it. Corresponding sides of similar triangles are proportional. So once we had our proportion set up, what we did then was we cross multiplied. We did 6 times x and we did 2 times 9. And that is kind of what we talked about, our cross product rule. We know that when we do that procedure, we know it gives us a true equation. And then we solved it out. So today on these proofs, we're going to do the same thing. We're just going to be doing this with value, like with proof, non-algebraic questions instead of with numbers involved. But it's the same process. So we're going to leave this next one blank. I think the best way to show you this is just to show you an example. But here are the two new rules. We're going to be using the cross product rule, and we're going to be using the rule I just mentioned. So let's skip ahead. Let's do number 11. This is a good one. So let's get our statement and reason set up. And I'm going to show you kind of a really nice way to work through these proofs. All right, so I'm going quick, but pause if you need to. So we know angle G is congruent to angle J because it was given to us. So we're always going to look at what we're trying to prove. So let's take a quick look at this. We know angle G is congruent to angle J. So that's a really nice piece of information because remember, all we need is two angles. I don't want you to look at this and get all thrown off. When you see something like this, our goal is still to show that the triangles are similar first. And I'll show you a really nice way to work backwards here. So if you look back at our first example again, we ended up by doing our cross multiplying. That was our last step. In order to use that step, we had to first set up our proportion. All right, so these numbers had to basically go diagonally from each other up here. In order to use this proportion, we had to first prove the triangles were similar. So we're going to do the same thing in these proofs. I know in order to do this cross multiplication, I have to set up a proportion. And in order to set up a proportion, I have to prove my triangles are similar. So I'm going to start at the bottom here. I know my last step is going to have to be multiplying GK times KI and JK times KH. I know that has to be my last step. And that last step is when we do our cross product, our cross multiply. So I don't really need to do anything with the proof yet. I know that that has to be my last step. That's my answer. They gave us the answer. Now, in order to use this cross product, just like I showed you here, we first have to set up our proportions. So here's where we can kind of be a little clever about this. We can kind of find a loophole in the system. I know what my proportion is going to be, right? If I'm doing GK times KI, I know those have to be across from each other. They have to be diagonal, right? And in order for us to do JK times KH, I know those have to be the other cross product. So now if you were just to multiply these together, I know they're not numbers, but we can do the same thing with sides. So I can say GK is to K times KI equals jk times kh just by like working backwards and filling in my proportion. And I'm going to say it a little differently this time. This wording might make it a little easier for you. I'm going to say the reason I know this is true, I know that if triangles are similar, then their sides must be proportional. All right, so I'm not saying cheating the system, but I'm being clever here. So let's go up one more step. So let's recap. In order to use the cross product rule to get my final answer, I first have to set up my proportions. And in order to set up my proportions, I first have to show that triangles are similar. And we know that's going to be done by the angle-angle similarity theorem. So here's the one thing we have to be really, really careful about. What the heck triangles am I working with in this picture? I see a couple different sets of triangles, right? I see this one here. I see this one here. But I also see these overlapping triangles, right? So I see that one. I see this one here. So there's actually like 4 different sets of triangles to use. We have to make sure we're using the right ones. So here's how I'm going to do that. We need to look at our answer. I know that I'm using a triangle that has GK in it. So GK is right here. I know that I'm using a triangle with KI in it. So KI is right here. So I'm just going to darken in or use a highlighter or a pen or a pencil. I'm going to darken in these sides. I know I'm using a triangle with JK in it. So JK is right here. And I know I'm using a triangle with KH in it. KH is right here. So you can tell by doing that, it shows us which triangles we should be focusing on. So it looks like I'm working with those 2 triangles there. So when I fill in this last step, I know that I'm going to name this carefully. I know I'm going to be proving GKH similar to JKI. So I really haven't done much with my proof yet, but I have my last 3 steps done. So I want you to take a minute and just look at that. So you can see working backwards, we did a lot of the steps for this proof. So we know we're only looking for angles. We know to prove this similarity, we need to use angle-angle. They gave us 1 pair, right? They gave us a pair of angles in the given. So we only have 3 to choose from. I can do angle H and I, or I can do this angle, GKH and JKI in the middle. If I look at H and I, but just by process of elimination, I don't really think I know much about those 2. There's not much that I can tell. But hopefully what we're seeing really, really automatically now is I have these vertical angles. So basically my last step, I can say angle GKH is congruent to angle JKI because vertical angles are congruent. There's my second pair of angles, which makes the triangles similar. Since the triangles are similar, I know I can use my proportion. And when I have my proportion, I know I can use my cross product rule. So it's really cool. We can just work backwards on these proofs and it gets us a lot of the way there. All right, so 2 little things just to warn you about. First of all, you're going to see the word altitude today. We've talked a little bit about that, but what an altitude is, it's a line segment connecting the vertex of a triangle. Let me say that again, connecting a vertex. There's 3 vertices in a triangle, right? Any of the corners, connecting a vertex of a triangle to the opposite side at a right angle. So an altitude is a line segment connecting a vertex of a triangle to the opposite side at a right angle. So like for number 16, for example, if you're challenging yourself and working on these proofs, if I know AF is an altitude, I know it goes from the vertex here, connecting this to a right angle. So that would tell me that angle AFB right here and angle AFC are right angles because it's an altitude. So keep that in mind. Second thing, we have to be very thoughtful about what we're trying to prove. So sometimes what we did on the first level of these proofs, all you need to do, all it's asking you to do is prove the triangles are similar. So that's as far as you would have to go where my red line is there. Sometimes if you look at like number 9, all it's asking you to do is prove the proportion step. So if all it's asking you to do is do this part, you could stop right there where my red line is. If it's asking you to go all the way through and do that cross multiplying, that's where we'd have to go to that final 5th step. Okay? These questions like number 12 are a little more challenging because there's 3 triangles to choose from. So what you really have to look carefully for is which sides they're using. And then I would still highly recommend kind of drawing them out, big, medium, small. I think we all got really good at that last unit. And think about which parts we're using. And you'll still have to pick which one of these triangles we're using. You'll still have to cross one of them out. All right, so I hope that makes sense. I'll be here if you need help, and we'll talk to you guys next time. See you.